Hello. A very good evening to the dignitaries, faculty members, and all the participants. On the behalf of the organizing team call to this AICTE sponsored a 2-week FDP on computational biology in therapeutics and theranostics. All India Council for Technical Education (AICTE) was established in 1945 with an agenda to develop technical education in our country. Now, with AICTE Training and Learning ATAL Academy, their vision is to promote learning in the young faculty members to promote higher education. Allahabad was established in 1999 and is a center of excellence in the information technology and allied sciences. The institute conferred the deemed university status by the Government of India in the year 2000. Later on, in the year 2014, by the Act of Parliament, Government of India, the institute attained the status of national importance. Through the extensive research in the field of information technology and allied sciences, the institute contributes to the development of our country. The institute has been spread in 100 and is situated at Devghat, Jhalwa, Prayagraj, Uttar Pradesh. The institute is having well-established furnished infrastructure and is having well-connected internet connectivity throughout the whole campus. The departments that are running at IIIT Allahabad, there are 4 departments: the Department of Applied Sciences, Department of Electronics and Communication Engineering, Department of Information Technology, and Department of Management Studies.
So we can conveniently divide this hub as having a support side and as having a scientific side. So on the support side of this hub, we have all the information technology, how you manage the information, various software applications, databases, computational resources. That includes both the hardware and the software.
Now, Department of Applied Science is the integral component of our institute. It offers the programs in bioinformatics and biomedical engineering. The courses offered by Applied Sciences are offered to the students, five-year dual degree undergraduate students and 2-year postgraduate students and the PhD program. The department also contributes to the courses in the domain of physics and mathematics running in the other departments of the institute. The research under the Applied Sciences are the Lab of Biomass, Chemistry Laboratory, and Nanotechnology Laboratory.
So we can conveniently divide this hub as having a support side and as having a scientific side.
These are the 2 coordinators of this program: Dr. Nidhi Mishra, who is working as an associate professor in the Department of Applied Science, IIIT Allahabad. She works in the field of drug designing and drug discovery, natural product chemistry, synthesis of design drugs, green synthesis of nanoparticles, nanocellulose and nanocomposites, and computational biology and computational chemistry. And Dr. Shintu Kumar Samanta, who is the co-coordinator of this program. He works in the field of understanding the molecular mechanism of antibiotic resistance and biofilm, development of advanced nanoscale material to treat the bacterial biofilm infection, and development of potent drug molecules against small lung cancers using the in silico approaches. This is the small introduction about this program. This program will emphasize on the role of the computers in the field.
So we can conveniently divide this hub as having a support side and as having a scientific side. So on the support side of this hub, we have all the information technology, how you manage the information, various software applications, databases, computational resources. That includes both the hardware and
participants for the drug discovery through the practical approaches. This workshop will be a 2-week program, where in the online session, there will be lectures by the eminent speakers such as Dr. Rakesh Mishra sir, who is the director of Tata Institute of Genetics Society and the ex-director of CCMB, Professor Krishna Mishra, who is the honorary professor at IIIT Allahabad, Dr. Mohammad Imran Siddiqui, senior scientist at CDRI, Professor Ranjit Prasad Bahadur, professor in the IIT Kharagpur, and many other from the various pioneer institutes. There will be lectures on various topics and
so we can conveniently divide this hub as having a support side and as having a scientific side. So on the support side of this hub, we have all the information technology, how you manage the information, various software.
The offline session would have the hands-on training for the participant, where the participant would have the chance to learn the techniques of molecular docking, molecular dynamic simulation, immunoinformatics, microarray data analysis, and differentially expressed gene identification, protein structure prediction, ADMET properties prediction, and pharmacokinetics. Also, the representatives of the Schrodinger will also demonstrate their tools and takes the hands-on session as well. There will be a visit to the National Prayagraj, Uttar Pradesh for the participant. Both the online and the offline sessions will have the MCQ assessment, and the participants are required to participate in the assessment. And it is must for the participant to attend the.
So we can conveniently divide this hub as having a support side and as having a scientific side. So on the support side of this hub, we have all the information technology, how you manage the information, various software.
Be recorded. This is the small intro. Thank you.
So I welcome you all to this training FDP on computational biology in therapeutics and diagnostics. So we will started with today's session, and we have with us Dr. Imran Siddiqui from CSIR CDRI Lucknow, who is a senior principal there. I welcome you, Professor Imran Siddiqui. And for his achievements, I would like to tell you that he has done his MSc from AIMS New Delhi in biophysics.
So we can conveniently divide this hub as having a support side and as having a scientific side. So on the support side of this hub, we have all the information technology, how you manage the information, various software.
In Canada. Since then, he has been working with CSIR CDRI Lucknow. To his credits are several awards and fellowships, of which one is MSERC Visiting Postdoctoral Fellowship, Government of Canada, that he got in 2003 and 2004. Then the Federal Ministry of Education and Research Fellowship Germany gave him a postdoctoral position. National Center for Theoretical Physics, Italy, gave him Chronal and Subsistence Award for Conference on Drug Development for the Third World. He has received.
So we can conveniently divide this hub as having a support side and
South Africa Chronal and Subsistence Award. International Center for Science and High Technology has awarded him for Travel and Subsistence for an invited talk. International Center for Theoretical Physics has given him Travel and Subsistence Award for participation in military school. And International Center for Theoretical Physics gave him an award in 2015. He has a research group and an H index of 34. So we welcome you, Professor Imran Siddiqui, to this FDP, and I hope that all our participants will learn a lot by your lecture on recent trends in computer-aided drug design, virtual screening.
So we can conveniently divide this hub as having a support side and
on behalf of the organizing committee. So now it's over to you, Dr. Imran Siddiqui, to begin with your lecture.
thank you, Dr. And a very good evening to all of you. Dr. Nidhi, can you hear me?
Yes, yes. Voice is very much clear.
Okay. I'm having some sort of echo at my end. I don't know whether.
No, the voice is clear. Now you can share your slides.
So we can conveniently divide this hub as having a support side and the way it has been planned. I must congratulate Dr. Nidhi for covering many important topics that are very important for this particular area of research in current scenario. Okay, so let me share my slides with you. So we can conveniently divide this hub as having a support side and a hello.
Yes, sir, we can start. We can hear you.
Okay. So thank you. So we can conveniently divide this hub as having a support side and as having a scientific side. So this the theme of this faculty development program being organized by IIITA. Yeah. So I believe that most of the participants in this program are from background of life sciences or from computational biology or bioinformatics or associated areas. So maybe some of the colleagues may not be we can define this bioinformatics as a sort of central hub. I'm sure all of you know what is a hub. It's a central device that unites several disciplines and methodologies. So we can conveniently divide this hub as having a support side and as having a scientific side. So on the support side of this hub, we have all the information technology, how you manage the information, various software applications, databases, computational resources. That includes both the hardware and the software. Now, all of these provide the infrastructure for the bioinformatics and computational biology. Novel molecules and drugs. Scientific side of the hub the bioinformatics and computational biology is in the role of drug design and development of novel molecules and drugs, medical diagnostics and therapeutics. And the reason why we are here assembled today for discussing this issue. So computational drug discovery or the use of computers in drug discovery, this is not a new area. It is already a well-established scientific discipline in medicinal chemistry research and has been found to be critical. The success of this target-driven approach, this relies on advancement in bio as well as in cheminformatics approaches. And these all allow us combination and provide the driving force and the success of this target-driven route. These relies on advancement in bio as well as in cheminformatics approaches, and these all allow us of discovery process and provide novel approaches to the design of development of drugs. The main, the key objective is the development and application of integrative bioinformatics and cheminformatics methods that can be translated to support the modern drug discovery by designing novel drugs and to improve the human health. That's the ultimate goal of
Charger.
objects coded by different colors represented different different atoms, and there were these cylindrical sticks we used to represent the bonds, and we used to build models of various molecules using these attributes. And so this is how we used to do modeling in earlier times using plastic models. Activity. So these were physical models, mostly based on the molecular connectivity and the stereochemistry associated with these molecules. They gave some impression of the molecular dimensions and about the shape of the molecules that were being modeled. However, they were not so accurate, difficult to manipulate and store. That means we had a
Hello. Uh, Excuse me, sir. Sorry to interpret. Actually, your voice is continuously breaking.
these huge groups. Of course, they were difficult to manipulate. That means that suppose you made a model and then as to say carbon or sulfur, you put some other model, some other atom, and then the whole model has to be broken down and again has to build it again from the scratch. And of course, difficult to store. You have to make model and then disassemble it and make it assembly as another molecule. And so you cannot store one molecule. You have to disassemble and keep on making a new model from the same set of attributes. Often fragile and static means that these models, suppose it falls down and then it breaks into various. So each atom goes here, goes here and there, and so it's difficult to keep track of these. Gave very little information of the energy and other properties. So in a way, we can say it had more than higher number of atoms in a molecule, then these models become the complexity increases with the size of the atoms. size of the molecules. So very difficult to construct large models. Now, thanks to this advancement in computers, both in terms of hardware as well as in software, now we rely mostly on doing molecular modeling using computers, and these computer modeling allow access to the molecular information, which is useful for predicting properties and their uses, which was information or the chair easily doable with the mechanical or the plastic models in earlier times. So you can easily study whether the molecule has a boat conformation or a chair conformation, or what other properties could be associated with the structure, or how different fragments can be joined together to make a synthetically feasible molecule. Is it possible to do that way or no? How molecular assemblies undertake, how protein interacts, how protein DNA interacts, protein lipid interacts, and all sort of things that can be done thanks to all the molecular modeling via computers. And all of these help in understanding the properties. And if you understand the properties, and this will help in some useful applications of this. Now, some of may you may they were awarded 2013, around 10 years back. The Nobel Prize for the chemistry was awarded to these three gentlemen: Michael Levitt, Martin Karplus, and Ariel Warshel. And they were awarded the Nobel Prize in chemistry. And the headline was that the three get Nobel for taking chemistry to the cyberspace. Now, what does that mean? Now, when we talk about chemistry, we think that chemistry, the chemical experiment, ideally takes place in lab with students taking a test tube, adding some reagents, some color development, some reaction taking place, and so on. But the ability to carry them out in a real time through computers has awarded these three gentlemen the Nobel Prize for Chemistry in 2013. So their research in 1970 helped us to understand how exhaust fumes are purified, or how photosynthesis takes place in green leaves. This kind of knowledge makes it possible to find the best design for things like new drugs, solar cells, or catalytic converters for car, and so on. And so the Royal Swedish Academy of Science, while
Hello, sir. Sir, your voice is not coming, and actually, I think some internet problem is there. Hello. Participants, please wait for a few minutes. Sir is on checking for the internet connectivity. He's on hold.
Yeah, can you hear me?
Yes, sir.
Okay, okay. So when, which slide did you lost my voice?
Sir, it is stuck at Nobel Prize Chemistry.
So before that, were you able to hear me?
No, sir. The voice.
Oh, I really. So you were not able to hear me at all during my previous slides?
Actually, sir, there was just continuous.
So anyway, so I was telling about.
So please start from the Nobel Prize in Chemistry 2013 slide.
With the computers. You can easily study the molecular assemblies, whether it's a protein ligand, or any sort of interaction that is okay. So I'm sorry about, I don't know what is happening with the connectivity, but my connectivity shows it's all the full network, but somehow not able to communicate. So let me try to again go ahead with my presentation. So today we use the molecular modeling via computers, and these computers allow us access to the molecular information which is useful for with the uses. So whether you are studying properties of a molecules, whether it's a chair conformation or board conformation or various other properties, you can easily do with the computers. You can easily study the molecular assemblies, whether it's a protein ligand, or any sort of interaction that is under studied. So I was telling about this particular computational chemistry. The computational chemistry by the Nobel Prize was awarded to these three gentlemen in 2013, and for their seminal work in the area of computational chemistry. And so the reason why I am showing this, I'm showing this slide to bring this point that why the computers are important for its use in modern drug discovery. The application that are highlighted by these three gentlemen uh, has shown the way how the computers uh, can really guide the various application in chemistry as well. Before a single and their properties are important, can usually before a single bolt has been or a screw has been put into place in a in a workshop. And this is true for the car makers, the car designers, and so on. And one clear example, which will not go into the workshop and start building the aircrafts. First, they have to model it. They do all property calculations, various what is the wingspan, what is the tail spin, what is the ground clearance, how it's going to behave when it's airborne, and so on. So all the properties are first theoretically predicted, calculated before a single bolt has been or a screw has been put into place in a in the workshop. And this is true for the car makers, the car designers, and so on. And one clear example, which safer and less expensive way of doing things while we build models before actually uh, starting with the actual implementation of the project. Help in visualizing the actual models that will be implemented when the project is completed. So scientists use models to see how things work before they make the final product, and this is a much safer and less expensive way of doing things while we build models before actually uh, starting with the actual implementation of the project. So again, in full range. So modeling usually involves computation and graphics. So it has essentially two components. One is computation and another is graphics, so in which the atoms are arranged in closed shells. And these models helped him in understanding various properties and has in full range. So modeling usually involves computation and graphics. So it has essentially two components. One is computation and another is graphics. So typically modeling exercise can have
So please unshare the slides and then share them again.
sorry ma'am. Hello, can you see the slide moving?
No, sir, they are not moving.
No, sir. Slide is not visible, sir.
We are stuck at which slide?
Sir, Nobel Prize Chemistry 2013.
Oh, really? I think this is really some problem.
So you please unshare the slides and then share them again.
Sorry, ma'am.
You unshare the slides and then share them again because slides are not moving.
Are we still stuck up at Nobel slide?
Exactly, Nobel Prize slide.
Does it move now?
No,
No?
no.
Yeah. I think has been a lot of network difficulty because of incessant rain. It has been raining about in Lucknow here. Yeah.
Yes, sir.
Yes, sir.
Yes, sir. Now slide is moving.
Can you see it's moving now?
Yes, sir.
Yes, sir. Yes, sir.
Okay. So let us begin again. So I was talking about why there is a need for building a model in first place. So this is true for any field, not specifically for drug design, but any field where the three-dimensional shape of molecules and their properties are important. What the idea is, they will first do all sort of modeling. What is going to be the wingspan, what is the nose tilt, elevation, the models and the molecules using. They bring a new model on a workshop for manufacturing. Similarly, it is true for town planners, for township makers. They will make a models which helps you in actually visualizing the the models and the molecules using. For taking up the. So this is another example of Professor Harold Kroto with his bunch of fullerene models on his text. This model shows the geometry of fullerenes, and this has helped him in understanding various properties, uh, uh, which is a spatial, which includes the spatial arrangement of carbons in a closed shells, and helped him in understanding various properties of the models and the molecules using. Hello, are we moving or just stuck again at the previous predict and visualize?
Sir, the
No, sir, it's
slide is
moving.
on the Professor Harold Croto.
Yeah, is it moving?
No, sir. Yes, sir. Yes, sir. Now it's moving.
So typically modeling has two components. One is computation and another is graphics. So typically modeling exercise can involve how you predict and visualize the shape and the properties of various molecules. These molecules could be the small molecules as well as macromolecules. You can compare the shape, the properties, examine prediction of molecular interaction, the reactions, investigate unstable and excited molecules, modeling of dynamic systems, vibration, diffusion, and so on, various dynamic. You can say, I want to change the models. This will help you in understanding what are various properties, the three-dimensional features that can be associated with molecules. So with the graphics, you can easily alter the display. You can change atoms, rotate bonds, color property. You can say, I want to change, so on. So we see that the spatial representation of the molecules, the models that have been built, has significantly improved as compared to the previously used mechanical or the plastic models that you used to do modeling in earlier times. These models are highly interactive. That means that you can simply sit in front of your molecules and in sort of a talk to the molecule. You can say, I want to change your, for example, phenylalanine to tyrosine and want to see how it is going to have an effect on the binding of the substrate or a ligand or a drug-like molecule on the computations. So quickly, just to recall that the proteins, these are an example of polymeric macromolecules, where the sequence of amino acids gives of more than one amino acid chains, and so you have a complex of uh, 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 amino acid chains coming together to form a sort of quaternary protein structure. So the important structure that is to be considered here in terms of when we talk about the computer-aided drug design is linked by hydrogen bonds. And so you get various secondary structures like alpha helix or beta pleated sheets and so on, or coil structure and so on. And then you have a tertiary protein structure. These occurs when of more than one amino.
So you're not audible again.
You have a quaternary protein structure is a protein consisting of more than one amino acid chains, and so you have a complex of uh, 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 amino acid chains coming together to form a sort of quaternary protein structure. So the important structure that is to be considered here in terms of when we talk about the computer-aided drug design is the role how the three-dimensional properties of a protein structure can be exploited in various drug discovery projects. Because structure of protein is directly related to the protein's functionality, even determining it. And so the reason for the research of 3D structures, the reason why we are discussing it today in this FDP program is it's because of its application in medicinal focus for docking drugs. Of course, there are other applications in agriculture and industry, which we are not bothered at in this particular presentation. So we will focus mostly on this, the first aspect that is in the medicines. Now, many of you also recall that there are various ways to study the protein structures. Well, there are three essential biophysical methods. One, which all you know, is what we call as an X-ray crystallography. And this is a biophysical approach which helps you in understanding three-dimensional structure of a target macromolecule, how a ligand binds, what is the ligand binding site, what is the ligand binding orientation, conformation, and so on. So use a crystallized protein Then you have a nuclear magnetic resonance spectroscopy. This is another method where you use a solution structure of a protein to determine the structure and functional groups of ligand, which are likely to be important for binding. And thirdly, it is a cryo-electron microscopy, and this is another biophysical method. In your is a cryo-electron microscope methods, which is useful for solving structures of transmembrane proteins. So based on these three biophysical methods, we have another theoretical methods, what we called as a molecular modeling or homology modeling based methods, which uses the experimental information in your these above three methods, namely the these methods work. But the idea of showing this slide in your in understanding and studying the three-dimensional structures of these methods. Now, once you have a three-dimensional structure of a protein or a another macromolecule with you, it is useful to look at the structures. Well, there are various free programs for doing this. Some of them you might have already used or you will be using in your hands-on sessions during these FDP programs. For example, the GRASS or Erasmol or Swiss PDB work. All these help in visualizing these macromolecules or the models. Now, most places with groups studying the structural biology also have commercial packages like Schrodinger or Sibyl or Discovery Studio. Schrodinger or so this is how some of the representation of how a protein DNA complex looks like in a Rasmol, which is a molecule Schrodinger, or as Dr. Nidhi mentioned, that you will have a hands-on training session by the and a DNA complex visualized in a Swiss PDB viewer is again a program presented by Swiss Institute of Bioinformatics and is on for viewing and building images models with complex computing tools. And so you can get beautiful models represented by various um, viewing or visualizing programs like Rasmol or SwissVideo. Of course, in addition, if you have Schrodinger or as Dr. Nidhi mentioned, that you will have a hands-on train session by the Schrodinger also during the later part. More than 2 lakh protein structure files have been deposited so far in this database, and the file. Now, if you look at the protein data bank, that is one of the database that you will probably have come across during this FDP on many occasions, is what we call as a protein data bank. This is a depository of protein three-dimensional structures. More than 2 lakh protein structure files have been deposited so far in this database, and the file contains text annotation and numerical three-dimensional atomic coordinates and so on. It also provides you various means to visualize molecules like in chyme or Ricemol and so on. And so you can access these molecules, the entries, by going to the home page, that is rcsb.org/pdb. So suppose if we are working on a protein structure in CDRI at Lucknow, for example, by studying these the structural properties by either X-ray crystallography or NMR, we can take deposit these coordinates into this protein data bank, and then the coordinates of the same protein can be downloaded by various academic groups or anywhere by simply going to the protein data bank, or also following various links like Ontrace or BLAST, and they can search the protein of their interest and then download the coordinates and then go ahead with the further structure-based or rational drug design approaches using that coordinates. So these pharmacophores. And also we know that with the very few exceptions, mostly the drug interact with macromolecular targets, most often with a specific binding site of membrane-bound or nuclear receptors, enzymes, transporters, or ion channels. So this relationship between the drug and the molecular target can be understood is dependent on the three-dimensional placement of specific functional groups and what that we call as a pharmacophore. So in any given molecule, the whole function, the groups are, or the whole molecule is actually not important. It's the specific placement of specific functional groups or the pharmacophoric groups in a particular conformation that provides the activity to a molecule, and understanding these pharmacophores and mediated by these pharmacophores. And also we know that with the very few exceptions, mostly the drug interact with macromolecular targets, most often with the specific binding site of membrane-bound or nuclear receptors, enzymes, transporters, or ion channels. So this relationship between the drug and the molecular target can be understood the protein, the binding site of the specific is, if you compare as a keyhole where the key has to be in the specific block or the PDB structure that of your interest to you in any specific drug discovery project. So the study of the protein structure provides the detail of the log, and if you know the log structure, you can design and identify the suitable key. You can go to the PDB, that is the collection of the logs for that matter, and you can find the specific log or the PDB structure that of your interest to you in any specific drug discovery project. So the study of the protein structure provide the detail of the log, and if you know the log structure, you can design and identify the suitable key based approach. Either from X-ray, the NMR, or molecular modeling. And based on the structural properties, you use various softwares, algorithms, and design or identify a key that fits well into the active site of that particular targeted protein. Based approach. So this brings it to the rational drug design concept. So three-dimensional molecular structure is one of the foundation of the structure-based rational drug design. And this offers some of our best hopes of putting an end to many diseases. This relies on the knowledge of the structure of the target protein. Based on the structure of the target protein, you can classify them as a receptor-based approach. So you use various methods like molecular docking or de novo design or virtual screening and so on. I'm sure you will learn more of these in this is why DQSR methods, AI-based methods, machine learning-based methods, and so on. So if you look at the structure-based drug design concept, then the basic idea of this is to identify a better key for a given log. So if once you know the structure of a protein, you can use it for structure-based drug design. One way of doing this is by what we call as a virtual screening. It involves computational filtering of a large body of molecules, which is generally a database, a compound database. And from that database, you identify those binders that have a high probability of activity in a biological test system. So you have a set of molecules in a database, and you have your targeted protein for which the active site is characterized. So you blast the whole molecules into the active site, and you segregate binders from the non-binders. So how you do this? By and this, for example, you can see one of my very earlier PhD student who took this experiment where she used a protein from a malarial parasite, which is dehydroorotate dehydrogenase. And so if you can see, this is the three-dimensional structure of a protein, which is represented by alpha helicase and beta sheet and so on. The active site of this is characterized by various residues. If you can see, these are being popped up. Active site of the molecule. So what she did, she blasted a series of molecules, a database of molecule into the active site. So the program evaluates the binding conformation of each of the molecules in the active site and tries to rank them on the basis of the system. This is not on the basis of certain binding score, which defines the affinity, how better or worse is the binding affinity of a molecule with the active site residues in a molecule. So this is how you rank a system. This is not possible in terms of human resources as well as in terms of it involves a lot of that have the better chances of showing activity in the actual biological assay. So The whole idea is just to identify those binders that have a high probability of activity in the biological test system. So instead of taking, so suppose you have a 50,000 molecules in a database, it's not possible to assay all of the molecules in a biological system. This is not possible in terms of human resources as well as in terms of it involves a lot of money also and time. So the best way is to rationally identify certain set of molecules. So suppose you find that the top is the use of molecular docking, and this explores the interaction that occur when a ligand could be an atom, ion, or a molecule, your drug discovery project. Now, one way that you will also, I'm sure, will take in hands-on during your FDP sessions later on is the use of molecular docking. And this explores the interaction that occur when a ligand could be an atom, ion, or a molecule, so you have a small molecule which is, you compare as a space shuttle. It goes up into the space, and there is already a station, International Space Station there. This shuttle goes up into the space, and it has to go and docks at a specific sign. So it does not go simply in the space and place itself to. By understanding the interplay between a ligand and its receptor, scientists are able to design drugs that would block the docking site of goes and docks at the space station, and then there is an interaction. So the idea again, your molecule also has a specific docking site in a protein receptor or a enzyme or any. By understanding the interplay between a ligand and its receptor, scientists are able to design drugs that would block the docking site of goes and docks at the space station, and then there is an interaction. So the idea again here is to show how a molecule could disorders. So this is another example of more recent one in 2009. If you recall that Elon Musk SpaceX agency, they have sent unmanned capsule into the space, and then it goes and docks at the space station, and then there is an interaction. So the idea again here is to show how a molecule could and this is another example where you can see okay, so this animation is for some reason it's not working, but you can see this is a benzene protein ligand interaction and so on. And but most docking programs basically use the same principle to calculate bound structure. They look for the site of interaction between ligand and the target, and they have been classified based on the various algorithms like DOC or UDOC, which uses fast shape matching, or incremental construction algorithm by FlexX, or ProLead, AseptDoc, TabuSearch, or genetic algorithm, which is being used by Gold and Autodog or FlexiDog, or MC molecular Carlo simulation, where and this is another example on MCDog, docking, and so on. So there are various algorithms, but the idea is for looking for the site of interaction between ligand and the target. And this is another example where you can see. Okay, so this animation is for some reason it's not working, but you can see this is a benzimidine docking to overlays into the active site, redock into the active site of the protein by using the autodock. So what they found that their program autodock, once they extracted and tried to redock, you can see the overlay of both the one in the green is actually the crystallographic coordinates, and the one in the blue and red is the docked conformation of the same molecule. And so you see when it is overlays into the active site, it assumes the exact conformation that is being solved by the experimental method. So this highlights the power of the computing program, that it can predict how a molecule can actually interact in a protein, even if you don't use experimental methods like X-ray crystallography or NMR. So this helps you in cutting the cost in terms of both the money and and so on. So you make a choice of the protein target. Once target, you use you study the structure, the target by either the crystallography or NMR or homology modeling. Once you know the structure, you use either in silico screening by using docking, or de novo design, where you can make you can design a novel synthetically feasible structure, and so on. Once you identify something interesting, you test them in the assay. You find something active, you can improve the activity by redesigning to improve affinity, specificity, various pharmacodynamics and toxicity. And so this goes up in sort of iterative fashion. You look at the improved properties. Once you make a changes in the analogs, design new analogs, look at the complex structure, and this goes in the is there are various databases that can be used for screening them. For example, zinc is one of the commonly used, which is a collection of more than 230 million purchasable Mycobacterium tuberculosis. This has helped in using pharmacophore based screening to identify molecules that have shown very good inhibition in an experimental assay while using this virtually screening approach. Databases like PubChem or Drug Bank, ChemBank, molecules. So I'll simply skip this. So this is an example how a virtual screening studies had helped in identification of molecules of interest for Mycobacterium tuberculosis. This has helped in using pharmacophore based screening to identify molecules that have shown very good inhibition in an experimental assay while using this virtually screening approach. Similarly, there is another certain hits were shortlisted, and these were experimentally found to be very potential inhibiting the protein and have helped in further shortlisting into three very good scaffolds and that were taken up into the further optimization stages. Is an example of resulted in some novel scaffolds which were further optimized and minimized, optimized to develop further certain in a database of 54,000 molecules, and then certain hits were shortlisted, and these were experimentally found to be very potential inhibiting the protein and have helped in further shortlisting into three very good scaffolds and that were taken up into the further optimization stages. Is an example of with the improved activity in synergy with the computational. So one important aspect which tech is another important targets for developing anti-cancer agents, and the molecules that methods. Another example of check1 kinase is a serine threonine kinase. Define new molecules analogs out of this with improved activity in synergy with the computational. So one important aspect which tech is another important targets for developing anti-cancer agents, and the molecules that and chemical and from the data from HTS and combinatorial synthesis. These methods enable machine learning and deep learning. These have become an indispensable tool for drug designers to mine chemical information from large compound database to design drugs with important and precise biological properties. And these tech is another important targets for developing anti-cancer agents, and the molecules that employed these methods in conjunction with integrated pharmacophore virtual screening methods in various anti-cancer projects. Like here in this, if you can see, this DNMT is one of the important target for developing anti-cancer agents. Here it's a combination of virtual screening and machine learning methods have been used for identification. Tech is another set of molecules which have shown a very good potential in inhibiting the likewise the HDAC is another important targets for developing anti-cancer agents, and the molecules that Example of HAT inhibitors, again, this shows a combination of integration of machine learning as well as the classical in identification of areas. So classically, there are lots of many examples where the structure-based drug discovery have shown to be a very successful implementation. For example, like the ACE-targeted enzyme which are essentially the antivirals, or influenza neuraminidase, which is zanamivir, as an antiviral developed by Monash University in collaboration with Glaxo. These are some of the examples where the structure-based approaches have shown lots of potential. Harsh but disturbing facts, but 90% of the drugs that these are many occasions I tried to sort this out at my end. I'm not sure whether the problem was at my end or through, but what I believe that today the weather was really very horrible to say in Lucknow. At least it has been raining throughout the day mostly. I think mostly I'm using right now is a Wi-Fi connection. This probably that could be the reason. Biology and structure-based drug design. And all we have seen that this application of bioinformatics, cheminformatics, molecular modeling, drug discovery and development has reduced the annual cost of developing a new drug by 33%. So if you, and also the time taken for drug discovery by 30%. So is that these are many occasions I tried to sort this out at my end. I'm not sure whether the problem was at my end or through, but what I believe that today the weather was really very horrible to say in Lucknow. At least it has been raining throughout the day mostly. I think mostly I'm using right now is a Wi-Fi connection. This probably that could be the reason also for the overall scenario. And also apart from the advancements in the rational drug designing approaches, we have seen large-scale generation of multidimensional biological data that has geared up the ML, DL, AI-based models development, and this has shown improvement in the prediction accuracy and also in time complexity compared to the traditional approaches. And also, there is a important thing is to note here is that these are many occasions I tried to sort this out at my end. I'm not sure whether the problem was at my end or through, but what I believe that today the weather was really very horrible to say in Lucknow. At least it has been raining throughout the day mostly. I think mostly I'm using right now is a Wi-Fi connection. This probably that could be the reason also for a poor network quality. Is playing its role in the overall process of this. So I must end with this comment here. I'm not sure how is or because there were lots of I saw the comments in meeting that there's a leaking of voice many occasions. I tried to sort this out at my end. I'm not sure whether the problem was at my end or through, but what I believe that today the weather was really very horrible to say in Lucknow. At least it has been raining throughout the day mostly. I think mostly I'm using right now is a Wi-Fi connection. This probably that could be the reason also for a poor network quality. But having said that, I must thank again for
Thank you so much, Dr. Imran Siddiqui. Now we have
synthetic
there is one in the chat box. What about natural products for different diseases? How to screen them?
synthetic molecules. The natural products can also be studied using molecular modeling approaches. Whether you want to study the interaction of phytochemicals, also various methods are there that will help you in.
So one Shivam asks, what about natural products for different diseases?
So what is the question?
He wants to know how to screen natural products, phytochemicals basically.
So phytochemicals identification. So no, phytochemicals can be like the organic or synthetic molecules. The natural products can also be studied using molecular modeling approaches. Whether you want to study the interaction of phytochemicals, also various methods are there that will help you in. There are important metals
in the online board. IIT Allahabad thanks him a lot, and thank you so much. She holds a doctorate in clinical psychology, and she has done courses in advanced clinical techniques and Albert Ellis rational emotive therapy at the University of Wisconsin. Dr. Bruta has been the president of National Academy of Psychology and Sambhavta, which is an NGO.
these methods. So if you have any specific question on phytochemicals, so it would be because I really didn't get the question what exactly he wanted to know. So I see there's a question from Sakshi about the role of metal complex. She asked whether the metal complex, of course, there are important metals
in the online board. IIT Allahabad thanks him a lot, and thank you so much. She holds a doctorate in clinical psychology, and she has done courses in advanced clinical techniques and Albert Ellis rational emotive therapy at the University of Wisconsin. Dr. Bruta has been the president of National Academy of Psychology. We'll send a question via mail to him, and I think there is some network problem, or I cannot even see him logged in. So we thank Dr. Imran Siddiqui for this interesting talk, and I present a virtual memento to him for being our first speaker in this FDP in the online board. IIT Allahabad thanks him a lot, and thank you so much. She holds a doctorate in clinical psychology, and she has done courses in advanced clinical techniques and Albert Ellis rational emotive therapy at the University of Wisconsin. Dr. Bruta has been the president of National Academy of Psychology and Sambhavta, which is an NGO dedicated to uplifting the mental health of the psychologists. And next lecture that we have, she holds a life skills, basically significance of life skills training in technical education. Now, are you here? So, we would like to take a break of just 2 minutes and call the speaker. She holds a doctorate.
Am I to begin, Nidhi?
Ma'am, I'll just briefly introduce you. Dr. Bruta is a retired professor from Department of Psychology, University of Delhi. She holds a doctorate in clinical psychology and she has done courses in advanced critical techniques and Albert Ellis rational emotive therapy at the University of Wisconsin. Dr. Bruta has been the president of National Academy of Psychology and Sambhavta, which is an NGO dedicated to uplifting the mental health of the citizens of India. She is editor of the Journal of Research and Application in Psychology. Dr. Bruta has been conferred with Lifetime Achievement Award by Indraprastha College and Global Indian Award for Excellence in Psychology by Global Indian Congress, San Francisco. She won the Baburam Award for Best Research Paper for her article in the Journal of Personality and Clinical Studies and was declared Educationist of the Year by Raja Ram Mohan Roy Education Society. Dr. Bruta has conducted trainings across frontline, middle, and senior management levels for various corporate houses. Her client list includes companies like Jet, Amway International, Vico, Modi Xerox, Renwexy, LG Electronics, HCL, Ram Organics, and many more. She is a consultant for recruitment to Indian Oil, HPCL, Indian Airlines, and Alliance Air. She has conducted talks for students, parents, and teachers at various leading schools across Delhi. So I welcome you, Dr. Aroona Bruta, and I would like you, ma'am, to start your video.
Well, can I start?
Yes, ma'am. I'm sharing your slides.
Full and visible.
Ma'am, you are audible but not visible.
Am I visible?
No, ma'am. Start your video. Start video. Yes, ma'am. Now you are visible.
Yeah, thank you. Well, Nidhi, thank you very much for having me over or having even thought of me. Am I addressing students? Nidhi, am I talking to students?
Yes.
Yes, ma'am.
Okay. Well, first of all, let me say hi, students of engineering. And I want to share my experiences at various organizations, which you will also join after doing your course. And I don't want my lecture to sound a lecture because I want to reach out to each one of you, because I know that when you are coming for professional courses, you are very keen to join an organization and start earning and stop requesting your parents for your expenditures. So when Nidhi ma'am asked me to speak on significance of life skills in technical education, I was wondering what life skills should I emphasize on, because the time allotted to me is in a way short and in a way adequate. But the kind of examples I'm going to give you, that's going to reduce the time taken. However, whosoever is at your end, Nidhi, may we start using our PPTs, and please let me use the first PPT, which is entitled Soft Skills and Hard Skills.
Yes, ma'am. We are sharing.
Right, soft skills and hard skills. Let me question the students if they are listening. Why are life skills called soft skills? It's really amazing because, on the one hand, you talk of life, which is basic to anything, and then on the other hand, you talk about soft skills. It's such a conflicting statement. And the hard skills that you talk about is your professional training, like if you've taken chemical engineering, civil engineering, computer science, or whatever you have done. You call those hard skills. Well, probably you call them hard skills because they are hard to understand, hard to conduct. But once you're trained in them, they are not hard to conduct, but they are hard to convey, to administer without your so-called soft skills. And I think we need to debate over here. Let me give you a personal experience. From 1982 to 1986, what am I talking? Sorry. From 2008 to 2015, I was a consultant to a multinational organization, which was a petroleum organization. It has lost its significance. It was a blue chip company at that time. To come and work with them for 2 days in a week as a consulting psychologist. They said, Dr. Bruta, why don't you come on board with us? Because if we start sending our staff to you, they'll be traveling all their life and doing no work. So I said, fair enough. As they saw my work, they asked me to join with them on an induction program. Why I am mentioning this? Because all of you will go through induction programs when you join some workplace, some multinational, some organization. There are induction programs, means giving you an orientation what's going to happen in the company and what will be your role in the company for whatever you have been selected. That's called an induction program. So when the chairman asked me to join the induction program, they asked me to speak on stress management. And obviously, I'm the last guy on this earth to be talking bookish, because I wanted the stress management workshop to be meaningful to the I was going to say student, but to the newcomer in the industry. So before I conducted the program, I started sitting with the newcomers, asking them their problems after 20 days of work in the organization. That is when they conduct their induction. So I must give you the verbal protocols of the newcomers. They said, too much listening. We can't question them. We are afraid of them. Too much listening. Another boy said, I cannot misbehave over here. I have to be good. I have to be disciplined. How can you remain disciplined throughout your day? How can you do that? I have a different role. It's so new. I think I was okay as a student. I could go to the class. I could cut a class. I could answer back a teacher. The teacher could make out from my face that I don't approve of him. Caught him here, I said. That's a student, and that too in India. Because your professional charges, your fee, is less than what it would be in the US. And he gave me a very dirty look, Am I challenging him? And I said, no, sweetheart, I'm not challenging you. But I'm trying to tell you, wake up, you've grown up. You're no more a student, because a student continues to be a kid, right? So the other guy spoke up and said, God, it's so bad over here. It was fun in the institute. It was such great fun. I was to myself. I could draw. I could paint while the lecture was going on. But here, oh my God, look at these big guys with fat guys. Note the word fat, right? But I said, you are here and there is no professor and you have to work. So I said, there a professor was a teacher. You can take the boss as a professor. He said, no, don't teach me that because I can answer him back. And the day I answer back somebody here, I will lose my job. I said, so are you worried about your job? He said, of course, this is the first time in my life I'm going to earn money out of what I have learned from my education. And I will no more have to answer my parents as to where I'm spending the money and why I'm spending the money. One girl got up and said, ma'am, I don't like one thing. I said, what? I came here, I asked my boss, teach me something, what you were speaking about. He said, didn't you study hard? Didn't you understand this in the engineering class? And she said, I just looked at him and said, oh my God, no wonder you're an old man and you're not young. You don't understand anything. Reading a book is very different from applying the book into practice. Well said. These are some of the verbal protocols that the newcomers were sharing with me. So, what was their stress? To be quiet, to be reticent, to be listening, not showing it on their body language, what they like and what they don't like. And yet, if you want to be successful, your soft skills should be hard, should be perfect, because you're not going to have tests and exams over here, but you're going to be evaluated. There will be an appraisal at the end of the year, and that will determine how your performance has been analyzed. So आप सुन रहे हो मेरी बात? आपको लग रही है कि ओहो ये तो रोजमर्रा की बातें बता रही है, बट ये रोजमर्रा की बातें आपको एक दिन सक्सेसफुल बनाएंगे। और अगर ये रोजमर्रा की बातें आपको याद नहीं रही और आपका एटीट्यूड पॉजिटिव नहीं रहा और आप ऑटोक्रेटिक हो गए, डेमोक्रेटिक नहीं हुए, you're not going to be popular, you're not going to be wanted. You will take the curses when you become a boss. So I start with that and I say, hard skills are the skills that you get through your educational degree. लेकिन आपके इंस्टीट्यूट में सॉफ्ट स्किल्स कौन पढ़ाता है in terms of personality, communication skills, body language, ये सब कौन कराता है? सोचा ही नहीं कभी.
One.
Now I will share with you something else. Let me go to the next slide, please. Nidhi ji, someone who is working, or is it some other person? Let me look into some personal life skills is the next PPT. Can we have that? Yes, thank you. Okay. So, isme, what are we going to do? Self-reflection. Every week, you must sit down, be quiet, and analyze your behavior. Did I feel threatened by anybody? Was I being looked down upon by anybody? Did people give me a pleasant smile or were they rude to me? And then you do self-evaluation. Was I able to handle the situation? Was I able to impress people with my knowledge? But as a psychologist, I will say self-evaluation करनी आती है, क्योंकि सेल्फ को हम कैसे एनालाइज करते हैं अगर हमारे में इंफीरियोरिटी कॉम्प्लेक्स है, अगर हमारे में लो सेल्फ एस्टीम है, अगर हमारे में क्रिटिकल थिंकिंग की एबिलिटी ही नहीं है कि नहीं ये किसी और तरह भी हो सकता था, नहीं ये तो मैं एनालाइज कर सकता था, बॉस को कम आता है, मेरा नॉलेज अपडेटेड है, कहीं जरूरत से ज्यादा अपने आप को सुपीरियर तो नहीं समझ रहे हो? ये आपको बहुत सोचना चाहिए। अब जो आपको WHO की लिस्ट है फॉर लाइफ स्किल्स, you will find a long list, but I will talk what I have experienced in the various organizations where I've been a psychologist and a consulting psychologist. Interpersonal skills हमारे क्या हैं? बॉस अभी तक घर नहीं गया, मेरा टाइम खत्म हो गया, क्या मैं चला जाऊं घर? बदतमीज तो नहीं लगूंगा, बुरा तो नहीं लगूंगा, बेहया तो नहीं लगूंगा, क्या मैं खाली बैठा रहूं अपने डेस्क पे, कुछ कंप्यूटर पे और करी जाऊं पर वो ना करूं जो मुझे काम मिला है, क्योंकि इंस्टीट्यूट से आदत पड़ी हुई है कंप्यूटर पे खिसकने की, कमरे से खिसकने की नहीं, कंप्यूटर पे खिसकने की, किसी और साइट पे चले गए. So you have to think of that. Can I do it now? Will there be work-life balance, or will there be a total work and no play? Will I be able to follow my boss, or will I be able to talk to him, or will I be able to defy him? Will he understand? So all these anxieties should be resolved if you have personal life skills. यानी कि अगर अपने में क्षमता है पॉजिटिव सोचने की, ये बहुत इंपॉर्टेंट है आपके लिए. अगर आपका ये एटीट्यूड रहा, अरे देखी जाएगी क्या होता है, हंस सकते हो. क्यों? जो आपका बॉस है, एक उसकी ईगो है, दूसरा उसकी ईगो स्ट्रेंथ है आपको समझने की, तीसरा हो सकता है उसकी एंगर मैनेजमेंट ना हुई हो और आपकी भी एंगर मैनेजमेंट नहीं हुई. आप में भी क्रोध आता है तो आप बेकाबू हो जाते हो, और आपके बॉडी लैंग्वेज से, चेहरे से, आईब्रोज से, श्रंकन आईज से, गुस्से से ऐसे देखने से, कटाक्ष, बॉस को भी पता लगता है कि आप क्रोधित हो. एंड क्या ये मैसेज जो आपका केवल चेहरा दे रहा है, क्या आपको अच्छा इंप्रेशन देगा? मैंने नहीं कहा कि सिर्फ मस्का लगाओ, मैंने नहीं कहा मक्खन लगाओ. मैं बात कर रही हूँ सेल्फ रिफ्लेक्शन की, जिसमें मैं ये भी देख रही हूँ कि रिजिलियंस बहुत इंपॉर्टेंट है। रिजिलियंस क्या है बताओ? मान लो आपको मैं अच्छी अच्छी बातें बता रही हूँ, आइडियलाइज्ड सेल्फ बता रही हूँ, जो कि आप में भी कमियां हैं, मुझ में भी हैं, और आपके बॉस में तो हैं ही हैं। क्या आप अपने बॉस को बर्दाश्त करने की क्षमता रखते हो? Are you able to digest what he talks? And I want to give you an example over here. I have a 42-year-old man coming to me for counseling. And he narrated to me, "Ma'am, I am in severe trouble." I was saying, "Okay, what happened?" And he said, "My super boss, not my immediate boss, but my boss's boss, came to my desk, threw a document at me, and said, 'You know nothing. You don't know how to work. I think you're not 42. You look silly and you look stupid and you act stupid.'" So that means the boss has no communication skills. The boss has no empathy. Maybe the boss has an anger management problem. And this client of mine, he said, "Ma'am, मैं वहीं पे मेरा रोना निकल गया उसके सामने." I said, "You wept?" And he said, "Yes, I wept." And I asked him, "You are a he and you wept?" नॉर्मली आप लोग जब बैठते हो तो लड़कियों को बदनाम करते हो, अरे यार लड़कियां बड़ी जल्दी रो पड़ती हैं. He wept. Now a lot of people who don't have resilience, empathy, they will say, "अरे लड़की न मां लड़का होगा." Are you trying to say that boys don't have the right to cry? They do have the right to cry. What is my counseling for the girls? Because they cry so easily. I say, never cry before your senior. When you're going to work, don't cry before your boss. You know why? That's the way of the world. He'll take advantage of you. What advantage? He'll scold you more. He'll scold you more often. You want to cry? Go to the washroom, go to the toilet, cry there, comb your hair and come back. Don't show that you're hurt, angry, you've lost it. मन नहीं लग रहा आज काम में, दोबारा दोबारा रोना आई जा रहा है. Don't cry there, cry in the washroom, in the toilet and come back. इससे आपके बॉस को आपकी वीकनेस नहीं लगेगी. So this was one thing that I wanted to point out, that bosses are human beings. They have their own complexes. They have their own stresses from their domestic life, from their executive life. They have borrowed a lot of money. They pay EMIs, then get into stress, and then take the stress out on you. Why? Because you're a punching bag. Why? Because you're junior. I know आपके दिल में उस समय आता है, तो मैं ही मिला हूं इसको. हाँ, आप ही मिले हो. Please accept it. You are now in the adult world and you are interacting with adults who are very moody, emotional, like children. एक बहुत बड़ी कहावत है most adults never grow up. That child in them is so prevalent that they start shouting and screaming at others. I had one client while I was in this petroleum company where I was working 2 days in a week. A young new entrant who was about 7, 8 months old in the organization came and literally wept like a child. And he asked me, मैं आपको आंटी कह सकता हूँ? कहो ना, whatever makes you comfortable. He says, मेरी मदर काम वाली के साथ कभी इतना बुरा नहीं बोलती जितनी मेरी लेडी बॉस मुझे चिल्ला कर बोलती है मेरे साथ. So I started talking to him. I asked him, is this your first job? And he said, yes. I said, what are your parents doing? They are in admin jobs in an engineering institute like yours in Delhi. So I said, fair enough. So they are very polite, they are very cultured. They speak even to the sweeper very, very etiquettely. But this lady who's my boss, she shouts and the whole office turns around. And I said, Beta, do you understand one thing? बदनामी उसकी हो रही है, आपकी नहीं. You have to understand that. वो कहता है उसकी कैसे बदनामी हो रही है, वो तो अपनी पावर दिखा रही है. मैंने कहा वो अपनी पावर नहीं दिखा रही, वो अपनी वीकनेस दिखा रही है. वो दिखा रही है कि वो कितनी टेंस है, कितनी नर्वस है in the position that she is in. And who was she? She was a team leader, जिसे आप short form में TL कहते हैं. So, in a way, what I'm asking you is that, and I'm sharing with you, is that there are all kinds of environments in your workplace which are like home environment if your parents are fighting. They are like road environments where you hit each other or bounce into each other or bang into each other and you start fighting on the road. Or you're like school children who bully each other, hit each other. Everybody lives that childhood because most adults never grow up. And why do they not grow up? Because हमारी country में no one wants to go to a psychologist. हम कोई पागल है, psychologist के पास जाएं. Whereas in other countries, they will say, oh, I need therapy. Please don't talk to me right now. In organizations over there, please don't talk to me right now. Let me have some therapy sessions and then I'll come back to you. So these are some of the issues which you should be now mentally prepared to face, how you will have communication skills. This will help you to achieve a lot of success in life. However, my major next point is the next PPT that I want to present to you. What does all this do to your health? May I have the next slide, please? Health and performance. If we look into the health records, we find newcomers, especially in organizations, in industries, wherever they are working, complaining of a word called psychosomatic disorders. Now, what is somatic? Soma is a Greek word which means body. means you will develop a lot of body symptoms due to psychological reasons. For example, stomach issues, loose stomachs, constipated stomachs, eating disorders. Either you would lose your appetite or you would eat more in anxiety, and headaches. Most common things happening. Lack of sleep, this will also happen. So we need to do some workout on our bodies. For that, you need time management, because you'll say, पिकअप आता है सुबह, कैब आ जाती है सुबह. Yes, cab तो आएगी. 8:30 you have to report to office, or if you're working from home in the pandemic and even now many industries, तो आपने अपना कंप्यूटर ऑन करना है, लैपटॉप ऑन करना है, whatever, जिस पे भी आप काम कर रहे हो, उसके भी टाइमिंग्स हैं. So you have to be very careful what time you wake up, what time you have a bath, or you skip a bath. You're not going to have a fresh mind. There's not going to be creative thinking at all. Because when you wipe your body with the towel, your blood supply improves to the brain. And that gives you creative thinking, alert mind, presence of mind, better grasp of things in your work environment. So you need to plan all that, for which what is important is sleep time, not what time you're getting up. For me, what is important is sleep time. अगर आप sleep research देखें, you will find, if you see the sleep research, the sleep that you get from 10 o'clock to 12 o'clock, that's the healthiest sleep that you can talk of. If you can take an EEG of your brain, and while you're sleeping, you will get the best alpha waves in your EEG that indicates that you're relaxed. After 12, the sleep is there, but there are spike potentials in your EEG, means now you're talking, you're thinking, you're imagining, you're dreaming, your unconscious mind is bothering you. उसने ये कहा, उसने वो कहा, हाय मैं थका हुआ हूँ, मैं ये हूँ, मैं वो हूँ. But if you want to be multi-channel, and if you want to be multitasking, then you need to sleep in time. You cannot think like I was in the institute, I was on Netflix, I was on Amazon, I was on this site, I was on chat, I was whatever I was doing. I was up till 2 o'clock at night, because the next day is Saturday. I don't have to work. I'll wake up at 4 in the evening, skip breakfast, skip lunch. So you need to understand, a healthy body makes a healthy mind, and a healthy mind makes a healthy body. What skill do you need for that? Clarity of thought, self-discipline. Then you can multitask. Then you will have the patience to listen to your boss shouting at you. And then you will be reducing your psychosomatic disorders. That means your headaches, your stomach issues, which are out of anxiety, which are out of conflict. मैं इसको चाटा मार दूं, ये बदतमीज है मेरा बॉस. And you try to hold back your hand. नहीं तो मेरा आज हाथ उठ जाता. This is what you think. But if you have had good sleep and your headache is not there, your eating disorders are not there, you've eaten the right food at the right time, you will be able to manage yourself. My last slide to you. The next one, please. It is take psychological help. I'm so sorry to say, हमारी कंट्री में ये जो स्टिग्मा है कि मेरा दिल नहीं लगता, मैं अपने आपे से निकल जाता हूँ, आज शनिवार है ये हो गया, आज रविवार है ये हो गया, मुझे ये चीज बार बार हाथ धोने हैं, मेरा दिल धड़कता है पर मेरा ईसीजी क्लियर है, एंजाइटी, मेरा मन नहीं करता किसी से बात करने को, यूर गेटिंग लो, डिप्रेशन। तो आप कहते हो किसी को भाई अपनी कुंडली दिखाओ, अपना हाथ दिखाओ, अंगूठियां पहनो, तावीज पहनो, स्टॉप दैट एंड टेक साइकोलॉजिकल हेल्प, not to get better but to improve your personality, therefore improve your performance and get a good annual appraisal. It is up to you what you decide. हाथ दिखाना है, कुंडली दिखानी है, या थेरेपिस्ट से अपने प्रॉब्लम्स रिजॉल्व कराने हैं, this is what is very important. मैं अपना प्रचार नहीं कर रही हूँ, मैं कितनों को देख लूंगी, आप जहां हैं वहां बेशुमार साइकोलॉजिस्ट हैं, आपकी नगरी में तो बहुत साइकोलॉजिस्ट हैं और अच्छे अच्छे हैं, अपना एक साइकोलॉजिस्ट रखिए, बार बार उसको मिलिए, अपना बचपन डिस्कस कीजिए, तो आपका क्रोध, आपकी एंजाइटी, आपका ये काबू में ना रहना और अंट संट खाते रहना, बेवक्त पढ़ना, बेवक्त सोना, बॉडी पोस्चर नहीं ठीक रखना, ये लाइफ स्किल्स हैं। ये लाइफ स्किल्स नहीं है कि आप टॉपर हैं, दोज आर योर हार्ड स्किल्स, जितना मर्जी पढ़ लो। मैं आज यहाँ खत्म करती हूँ। I am not the one who will tell you कि इस केमिकल से ये बनता है और वो बनता है, इस कंप्यूटर में ये हार्डवेयर है और ये सॉफ्टवेयर है। मैं आपको बताने आई थी, निधि जी की बहुत आभारी हूँ कि उन्होंने मुझे ये मौका दिया आपसे मिलने का, हर स्टूडेंट को आपके इंस्टीट्यूट में मिलने का मुझे मौका मिला है कि मैं आपको कहूँ कि आप बहुत सशक्त रहें अपने जॉब्स में, सब अच्छे हैं, कोई कमजोर नहीं है, किसी के कितने मार्क्स हैं, किसी के कितने मार्क्स हैं, मार्क्स इज नो क्राइटेरिया, बट व्हाट इज द क्राइटेरिया, कितनों को आप अपने साथ ऑफिस में लेके चलते हैं, कितनों को विश्वास है आप में कि आप कंपनी को आगे ले जाएंगे, खुद को आगे ले जाएंगे और औरों को आगे ले जाएंगे। प्रणाम करती हूँ आप सबको, थैंक यू वेरी मच, गॉड ब्लेस यू एंड गॉड ब्लेस अस ऑल्सो, थैंक यू वेरी मच, बाय बाय, धन्यवाद।
Thank you, ma'am. Thank you for this wonderful talk. Ma'am, कुछ question answers आप लेंगी? So, participants, if you have any questions regarding this soft or hard skills.
मुझे समझ नहीं आई कि प्रश्न क्या था।
Ma'am, if anyone has any questions, you want any doubts to be cleared about, soft or hard skills, personality development, you can ask ma'am. So now I think we are at the end of the session, and thank you so much for giving this wonderful talk and interacting with our participants. Now I would like to thank you by presenting a virtual memento. We will be showing it on mail. So there is one Sakshi Gupta who says that there is a taboo in India that you cannot trust a therapist. and that's why people are scared to go.
निधि जी आपने मेरा निधि जी आपने मेरा नाम ठीक नहीं लिखा था, ब्रूट में ए खत्म कर दिया आपने।
So sorry ma'am, कुछ fault हो गई है, some spelling mistakes you will see in the certificates and everything. So I present a virtual memento to you, and I thank you on the behalf of organizing committee, and there's a lot of thanks from Triple IPA for presenting this beautiful talk and for making our participants aware about life skill management. Thank you so much.
Thank you. Bye-bye.
No problem. So, dear participants, now we come to our interaction session. So, I would like you all to type your queries regarding computer-aided drug design in the chat box, and you can unmute your mic and ask your questions. We are open to discussion.
Hello, ma'am, am I audible?
Yes.
Ma'am, the question should be regarding the previous two speakers.
Previous two speakers, anything that you feel you want to discuss during this, definitely keep a note after time, discuss it maybe when you come offline. So let us have a discussion. Participants are free to ask their queries and we will try to solve them.
Okay, ma'am. Actually, I wanted to know the. Hello, my voice is echoing.
You can ask your question.
Yes, ma'am. My question is that what are the parameters for studying the metal complexes via computational studies? So, what are the parameters which we have to
Actually, if
keep
you
in
have
mind?
to study metal complexes, you have to see first of all the kind of binding that is there. Because what happens usually when you use a certain program, these bonds, usually to organic molecule to the metal bond, are coordinate bonds.
Yes,
So
ma'am.
most of the softwares don't consider it bonded. When you perform your docking studies or anything, the bond seems to be broken, and thus it does not give you appropriate results. So either you have to use softwares that are basically designed for such inorganic complexes, or you have to put some other bond in place of coordinate bond.
Okay, ma'am. And ma'am, one more question. May I proceed?
Yes, yes.
Ma'am, actually, we have seen that there are few metals which are biologically active too. So, how can we, via computationally, how can we conclude that this metal is important? Is it any way, or I hope the question is wrong or correct?
You will do doctorate studies on some particular protein.
Ma'am, pardon?
You will have to do a doctorate study with some protein structure as a target. And,
Okay, of metal.
but that metal you will take it in the form of an ion only.
In the form of?
An ion.
Iron.
Hmm.
Yes, ma'am. Okay. Thank you. That's it from my side.
Okay, thank you so much, Sakshi. So participants, are there any queries regarding online, offline mode? Any topics that you want to be covered to discuss?
Ma'am, can I say something?
Yes, yes.
Ma'am, it will be better if you allow us for 5 to 10 minutes after every speaker speaks, so that we can
Actually,
ask them question in a go.
we will be doing it from tomorrow. Actually, with Dr. Imran Siddiqui, what was happening was some internet problem. Na? You must
Yes, ma'am.
have
Yes,
seen
ma'am.
that. So you couldn't remain connected after that. So from tomorrow onwards, we will be having question answer session. But today it was network problem.
Okay, ma'am. It's fine. That will be helpful for us.
Yes, yes. So participants can write in chat box whatever the queries they have, whatever uh, points they want to discuss further, so that we can take up all your queries in offline mode. Anything specific that you want?
Ma'am, brief or idea about the biological activities which a drug or the molecules we prepare shall be done.
Uh, Transit, you mean to say metal complexes?
Yes, ma'am. Metal complexes or organic molecule which we synthesize. So I want one session of that. How can we proceed for the biological activities which are to be done relating to the computational studies? Like firstly, we perform the computational studies and then we go for biological activities. So little bit discussion about this
Actually, we
topic.
will be discussing about our papers and everything. Then we will be discussing how to go ahead with the biological activity. Because
Yes, ma'am.
mostly what we do is we do the computational part, computational biology part, where supposedly you learn from literature that the kind of complexes, the kind of compounds that you are preparing have antibacterial activity. Okay, so then from literature we'll find out which protein they target, to which protein do they bind. And then we do the computational studies and we see their docking scores. And the top scorers then will go for wet lab activity testing. So that's will reduce your time and extend time and money in solving out the puzzle that your compounds, if they are showing a particular activity, then it is because of their binding to a particular protein. So this way we go ahead with different kind of diseases and their uh, and the proteins responsible for causing that disease. Mostly it happens that either the underexpression or the overexpression of the protein causes the particular disease.
Yes, ma'am. Okay, thank you, ma'am.
So, participants, if there are any questions or the topics that you want to discuss, or if you have any questions for Dr. Imran Siddiqui, you can type in your chat box and we'll send to him. So I'll give you almost next 5 or 7 minutes. If you have any questions, you can type in the chat box. So I think there are no questions from your side, or there are any? Okay, so there is a question from Chetan Kumar that multi-drug resistant strains are a nightmare for drug designing. Is it possible to tackle them? So Chetanji, it is very much possible to target them as well. We will be discussing 4 of our papers in which we have taken multi-drug resistant TB and these bacteria which cause multi-drug resistance, and we can target them as well. But you have to see what is the mechanism with which they dodge our human system, and we will be, when we meet in offline mode, we will be giving you details about those papers. You can go through them and try them when you do it yourself. Now we have Lokendra Singh Rathod, who asked how many molecules can be docked at times with the protein. So you can screen a huge library, any number of compounds depending upon the software that you use. But usually what happens is, if you are using AutoDock, you can dock one molecule at a time. You will have to do repetitive docking and compare the scores. So, any more queries? So I think that is the end of the session. Yes?
No more queries. I think then we can conclude today.
Okay. So I think there are no more questions. We will meet tomorrow, same time. Please log in at 6:45 p.m. because we will start sharp at 7 p.m. And I thank you all for this patient listening. And I hope this cooperation continues. And this is the end of the session. Thank you, everyone.
And I just would like to say, ma'am, one thing to all the participants. See, if you have any specific queries, immediately after the speaker's talk is over, when there is the question answer session, it's always good to ask them because they're more specific and they're more expertise in this domain. So already is always good if you have any specific queries. We are always there, the coordinator, to answer some basic queries. But you have any specific queries for a particular talk, so I request you all to please ask the concern clearly. Then your answer will be much more specific, it will be more satisfying. Okay. I think, ma'am, it's okay now. I think we can conclude for today. What do you say?
Okay, so we conclude for today, and Shreya has asked, we will be including tutorials on cytoscape. So that we will get an offline session. I think all the queries we have solved out, and you will be learning docking, molecular simulation, protein-protein interaction using cytoscope. All this we will be taking in offline sessions. I hope you all will join us, come to the IPA campus in offline sessions. So now, thank you everyone. Thank you so much. So I end today's session. I take your leave, and we will be meeting tomorrow, same time, 7 o'clock. Please log in 15 minutes prior to that. Thank you so much.